Hello, everybody. Since many of you were gone last week and I'm gone today at All-State Speech with the folks you see on your screen, I'm going to try and run through a PowerPoint with a few notes, and hopefully we can make this a productive day for everybody. You should remember that before people left to go to Nashville, we started talking about exponential equations, equations where the variable was an exponent. And remember, the way you solved equations like that was by dividing logarithms. You found the log key on a graphing calculator next to the 7, and what you did is you divided by the log of the number by itself divided by the log of the number by x. You should also remember the compound interest formula, A equals P times 1 plus R over N to the NT power. Remember, P was the principal, how much money you start with. A was the accumulated amount you're going to have after a period of time. R is the rate of interest, which you always put as a decimal. T was the number of years, and N was the number of times it's compounded per year. We're going to combine both of those things today to answer the question of when. We're going to look at the variable t in that compound interest formula and figure out when you will have certain amounts of money with compound interest. To get an idea of how these problems work, we're going to take a little bit of a trip back in time. We're going to look at some problems that people that were in this class 4 years ago made up when they were taking this when we went online during the coronavirus pandemic. These are problems that people that were in the class in the year 2000 took, and later on this year, you'll be writing some problems of your own that are kind of like them. So here's our first problem. It says Jeff Bezos puts $500 in an account. It makes 10% interest compounded daily. How long will it take for the account to reach $5,000? This is a really typical problem, and we start by just putting the numbers we know into the compound interest formula. We know we start with $500, and we want to have $5,000 at the end of the problem. It's compounded daily, so the n is 365, and the rate of interest is 10% or 0.10. What we don't know is the time, how long that's going to take to happen. Now, solving problems like this is not hard, but there's a couple of steps that you have to do pretty much every time. What we're basically going to do is get the parentheses by themselves, and I do that by first of all dividing A divided by P. Here I take 5,000 divided by 500. You can do that on your calculator, or you could probably figure out in your head that that just ends up being 10. So start by dividing A divided by P. Well, you don't have to write it down. What you essentially have now is 10 equals those parentheses to the 365t power. We're trying to figure out an exponent, so what we have to do is divide logs. I take the log of what's already on my calculator, that 10, and then I'm going to divide by the log of what's in those parentheses. Now, since there's also a number in the exponent, after I do all of that, I have to divide by that number. So here I take the log of the answer, divided by the log of 1 plus 0.10 over 365, and finally, I divide by the 365 in the exponent. You can see the answer here is like 23.029. That means it's just a little bit more than 23 years that it'll take for Jeff Bezos to have all that money. And here's a real similar problem. I'm going to read the problem, and then I'd like you guys to try to pause and see if you can set up the equation. Here it says, Emily puts $270 in her savings account. Her account earns 5% interest rate compounded monthly. The problem just says monthly, but that would mean compounded monthly. The question is, when will her account have $4,000 in it? So take a minute, pause the video, and then let's compare what the equation is. So here's another problem that's similar we're going to take a look at. What I want you to do is, after I read the problem, pause the video and see if you can set up the equation. It says Emily puts $270 in her savings account. Her account earns 5% interest rate monthly, and what that would mean is compounded monthly. The question is, when will her account have $4,000 in it? Again, take a minute, pause the video, and see if you can come up with the equation. You can see what we have here is 4,000, the amount we want to have at the end, equals 270, the amount we start with, times 1 plus 0.05, the rate of interest, over 12, because it's monthly, and that's all to the 12t power. Now see if you can divide and find out what the answer is going to be. And here I have it worked out. You can see that what I did is I divided 4,000 divided by 270. Then I did the log of that divided by the log of the parentheses, 1 plus 0.05 over 12. And finally I divide by the 12 that's in the exponent. We get an answer of just over 54, which means it'll take about 54 years before there's $4,000 in her account. If you need to pause the video to look at that and double check what you did, you can do that now. Here's one more problem, and again I want you to try to write out the equation and then see what you get for an answer with it. It says Tara puts $150 in an account. It earns 5% interest compounded daily. How long until the account is worth $1,000? Why don't you pause the video and see what you can get working that out. So here's our equation. In the end, we want to have $1,000. That's going to equal what we start with, 150. Then we've got 1 plus 0.05 over 365 because it's daily to the 365t power. And then to solve the problem, what we're going to do is start by taking 1,000 divided by 150. We'll do the log of that divided by the log of the parentheses, 1 plus 0.05 over 365. And finally, we divide by the number in the exponent, 365 again. Here we get just less than 38 years. We've got two more problems that we're going to look at. On our next to last one, you can see I illustrated it with some interesting bills. In the United States, we don't have either $5,000 or $10,000 bills anymore, but up until about the Great Depression, those were still valid things for circulation. Today, only banks deal with money that is that large, and the largest bill you can actually have as a person is a $100 bill. But at any rate, what our problem says is I put $5,000 into an earlier retirement account. The bank gives me 2.5% interest rate monthly, and again, that's going to mean compounded monthly. How long will it be until my account is grown to a net worth of $10,000? I'll let you pause one more time and see if you can come up with equations and answers. Well, the equation again, you start with how much you want to have at the end. That equals how much you have at the beginning. 1 plus the rate of interest over the number of times compounded per year, and the exponent is number of times t. And here that's 10,000 equals 5,000. 1 plus 0.025, which is 2.5% interest over 12 to the 12t power. And working it out, we start by dividing 10,000 divided by 5,000, which is just 2. We're going to do the log of that 2 divided by the log of the parentheses. And finally, we divide by 12. This time our answer is about 27 3/4. And here's our last example. It says Mary puts $1,000 in her account. The account earns 5% interest compounded weekly. How many weeks until her account has $10,000? So you can see these are all kind of alike. You start with a small amount of money. We want to know when you're going to have a big amount of money. And here it's just working out a little bit different. I have pretty much everything worked out here. Again, it's going to be 10,000, what we want in the end, equals 1,000, the principal. And I have 1 plus 0.05 over 52, because there's 52 weeks in a year. And that's all raised to the 52t power. And I started by dividing 10,000 divided by 1,000. We take the log of that, divided by the log of the parentheses, and the last step is always divide by 52. Now what this is telling me is that it's going to be like 46 years roughly for that. If I want to get really picky though, I could notice that the question is actually asking me how many weeks. Now, of course, there's 52 weeks in a year, so if I want to know how many weeks, what I've got to do is take the answer I had before times 52. Now, honestly, if I were asking you to do this problem, 46 years is fine, but technically it's like 2,396 weeks is what it would take as well, and that is the way the question's phrased. So again, the basic idea of what we're doing is solving for when. We're trying to find the variable t. And what I want to do is set up the interest formula, putting in all the variables we know. What should be left is t. And to solve it, we divide a divided by p. You divide the logs. And the last thing is always divide by the number in the exponent. So that's the basic idea of how to solve for the exponent in story problems.